Hello everyone, welcome to Data Chronicles. In this video, I'm going to teach you on machine learning based on projects. Here, I'm taking the dataset from Kaggle. It is a breast cancer diagnostic dataset. Now let us understand about the dataset. Features are computed from a digitized image of a fine needle aspirate (FNA) of a breast mass. So, what is this FNA? Let us understand from Google. FNA uses a needle and syringe to get a tissue or fluid sample from a suspicious mass in your body. So, this FNA is like fetch the tissues or fluid samples from a suspicious mass in a body. And then what is this FNA data says? They describe characteristics of a cell nuclei present in the image. So this data is characterizing the cell which are present in the image. And then let's get into the data. So in this table we have ID numbers and diagnosis data, which is malignant and benign. So what is this malignant and benign? So benign tumor, these are cells which are not cancerous and they won't spread. Malignant tumor, they are cancerous and can spread to other tissues and organs. So malignant is dangerous, whereas benign is not. And then we have the other cell nuclei characteristics like radius, texture, perimeter, area, smoothness, compactness, etc. Like they are from A to J. So this is the data. You can download it from your Kaggle and use it in Jupyter Notebook. So I have already downloaded and I'm moving it to the notebook. Now we can see the data here. We have the ID, diagnosis, which is where M stands for malignant and B stands for benign. So by seeing this one, we can easily say that it is a classificational project. We can see radius, texture, compactness, everything it is here. Now let's get into the notebook. First, we need to install the important packages. So the important packages are NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn. So Matplotlib and Seaborn is used for visualization. Pandas, NumPy used for data manipulations. Scikit-learn, it is used for machine learning and we like splitting and other testing things. Now first we need to import pandas, as I am importing pandas as PD, NumPy as NP. Next I am loading the data from a CSV file to panda using to notebook using pandas. So here is the code pd.read csv and the location of the file. If you want to read Excel, you have to use pd.read Excel. Then you can read other data and you can also read from database also. So after that we getting the data here. This is the data. Yeah, okay. Now I'm going to check the shape of this file. So data.shape will give me the output of this shape. So it has 569 rows and 33 columns. Now entering to do data pre-processing, we'll do a statistical summary here. So for that one we use data.describe. So here I'm going to get a statistical summary of it, data, numerical data. So let's ignore ID, radius mean. So there are 569 rows and the mean is 14 and standard deviation is 3.5, minimum is 6.98, and these are the quartile: first quartile, second quartile, third quartile, and then maximum is 28. Then like that we get a statistical summary by using this code. Then we need to know the information of each cell. Now if I go with the data.info, it is saying that id, it is an integer value; diagnostic, it is an object which is string, like that; and radius and all, which has a decimal points, so it is showing a float. Now data.columns will give me the list of columns which are present in the data. Here id, everything is here. And now I need to select only the object types in the data. So for that one, I'm using data.select dtype include object.columns. If I want to select only the float, I define here float 64. If I want int, I'll give int. Now when I'm getting the output as diagnosis. This is the only output. This is the only column with object data types. Next, I need to check is there any null value or blanks. So when I check here data.isNA.sum, so I'm there just fetching any is there any null value in this one, and I'm just calculating it for each rows. There is by looking at the output, I can say that there is no null values from till here, but one column which is unnamed.32, which has 569 null values. So with this data, I can easily say that unnamed 32 has no meaning in this data. So I'll drop this, I'll delete this column. So for this one, I'm using data.drop column name. I'm giving column name unnamed.32. Next, I'm going to deal with categorical data, as it is a classification problem. Now I'm going to check how many unique values are there. Sometimes they'll give small m or small b, capital M, capital B. This will create like a duplication of the classification. Now in this, I can easily say that there are only two data, M and B, which is malignant and benign. After this one, I'm just going to easily change from normalized data to differential data. Here if I say malignant and benign, it will be hard to analyze for a machine, so I'm going to drop one malignant. I'll keep malignant and drop benign, where malignant will state it as 1 and benign will be 0. So when we check here, the diagnosis underscore M, which is malignant. When it is a malignant, the data will show as 1. When it is benign, the data will show as 0. Now coming to visualization part. Now we have all the data, and by just looking at the numbers, we don't get a clear picture. For that one, we go for visualization. So for visualization, we use matplotlib and seaborn. Now first we need to check how many data as malignant and benign. We'll just separate this one. Here in this data, I can easily see that malignant and benign were zero states as benign, and one states as malignant. Now let's see how much data consists of that one. For this one, I have used just a print statement. See, total M value is 212. So malignant values are 212 and benign is 357 out of 569 rows. Now we need to do a correlation matrix and heat map. So correlation means it will correlate each rows with the categorical data. So here the categorical data is diagnosis underscore m, which is an object. So for this one I'll correlate with each and every columns. For that one we are using data. I'm going to duplicate the data by dropping the m value, like my diagnosis underscore m, to a new data set. Now for this one I'm going to correlate it with diagnosis underscore m and plot a bar chart. So this is the data for a bar chart and to correlate it with. Next, by looking at this one, we can see that this symmetry mean as negative correlation and texture as negative correlation and smoothness as negative correlation and concave point as negative correlation. The other columns have positive correlation, whereas the concavity worst as highest correlation. By just looking at this data we can't analyze. So for this we go with heat map to see the visualization of each rows and like correlation. Now I'm going to fetch the correlation. This is just a numerical representation of this one. Now I'll plot a heat map for this correlation. Now we can see that the heat map, the ID and ID will have always be the highest correlation as they are same. Here in this we can see the lighter the color has highest correlation and the darker the color lowest the correlation. By seeing this color map, heat map, I can easily say that these represent higher correlation, and here also higher correlation, and here there is a higher correlation, and here also we have higher correlation with each columns. Now by seeing all these data, we'll start applying the machine learning techniques. Now let's go by splitting the data. Why we need to split the data? We need to split the data because we have one data set, but we need to train and test it. For training purpose we need a patch of that data, and on basis of training we need to test that one. So I need to have a test data. So this will help me for future prediction. Now I'm using sklearn, which is scikit-learn. So here I'm importing a module train test split, which will split my data into train set and test set. So for this one I'm using sklearn dot model selection import train test split. Now I'm making x and y two data. So where x will not contain diagnosis underscore m, id we don't need it, so I'm dropping this one. Y axis, y data will be having diagnostic underscore m. Now I'm splitting the data. So x train, x test, y train, y test. Now train test split bracket x comma y, where the data I'm taking it, and I'm using a 0.2. So this will convert the 100% data into 80% of for training and 20% for testing. And random state, it is a it will never change its data when every time I do this splitting. Now I'm checking the shape of this one, x train shape, it is 455 and 30. So it is having 455 rows and 30 columns, whereas 455 rows out of 569 rows, so it has divided 80% to the training set. Now looking at X test. After train test split is done, we need to do a feature scaling. For this one, I am using a scalar.preprocessing standard scalar. This is a method for importing this standard scalar. Now I am assigning standard scalar to SC. Now I'll transform this one. So for us, we can see that data in a table format, but machine can't understand. For that one, we have to normalize this or future scale this one to make machine understand. By using this sc.fit transform, it will convert the data into a numerical array form. So first, if we are using the first time, we have to use fit underscore transform. If you are using it for next purposes, you can use transform. Now coming to logistic. So after feature scaling, we need to implement it for machine learning. Now we can see I'm going to first try it with logistic regression. So for this one, I am importing logistic regression from scalar. I am just assigning it to LC as LC. I am fitting it lc.fit xtrain, y-train. So I am training the logistic regression using xtrain and y-train. So I am saying for the x values, y value, these are the y values as output, and you need to train on this one. Now after training, and I need to do prediction. So now I am doing prediction. Now what is happening is lc.predict xtest. I am loading xtest. So I am saying logistic regression to evaluate the xtest data and give me the y output based on the training you have done previously on xtrain and y-train. Once I have done, I need to check the accuracy and everything. So for this one, I am going here. I am importing the metrics like accuracy, precision score, F1 score, recall score, confusion matrix. I'm going to explain each and every matrix in the later videos. So I am using this one. Here we can see that the accuracy of the model is 96% and F1 square is 95%, precision is 95%, and recall is 95%. In this one, I can use a confusion matrix. So this confusion matrix will give me how many outputs are correct and how many outputs are false. Here it is saying that two values are false, and then I'll do cross validation for this one. So by using cross val score, I'll get an accuracy of 97%. So I need to do cross verification like we generally do in everything, and standard deviation is 1.97. Now we can't rely on only one model. Before implementing any project, we need to try it on different models and get the best out of it. First I did with logistic regression. Now I'm dealing with random forest. So here I'm importing random forest classifier. Here I am stating this one same just like what I did with logistic regression. I am doing the same with random forest classifier. Now we can see that accuracy is 96% and both are almost same, and here also little bit better in random forest, but precision score logistic regression is better. When it comes to recall score, random forest is better. Now we'll see confusion matrix. Here I can say 3:1 is like false values. When I do cross validation, accuracy is 96% and standard deviation is 3%. I can see that when we do cross validation, logistic regression is a better accuracy than random forest. So by doing these things, I can see which model is better. Now I need to do it parameter tuning, hyperparameter tuning. What is hyperparameter tuning? It is like I have a bike and it is going like 100 km top, and I need to enhance the speed of this one. What I do, I use a higher grade petrol, or I am going to tune the carburetor or a fuel injector. Same way we are doing the tuning here also using random search CV. So these are the parameters. You can get these parameters from sklearn website. So I have downloaded everything from that one. Now I am doing a random search. Randomized search CV. What it is doing is it will just use each and every parameters, and then it will keep on tuning and finds the best fit for this project. Here we have given penalty, C, and solvers. These are the solvers. So this will like estimator. I used LC. LC means logistic regression. As I have seen that LC has better accuracy than random forest, I am using LC. Now param distribution, I am giving this parameter here, and iter. N iter means how many iteration it has to take to get the value. I am stating it as 10. You can give it based on your understanding. Scoring, ROC-AU. I am using ROC-AUC as for scoring. The better the ROC-AUC, the better the results. Then N jobs. It has to how many jobs it has to do. It is like that. CV, and then verbose is equals to 3. For this one, the data it calculates for each and every parameter, and it keeps on tuning, and it will give me the best output here. So it is giving me the best output here. Now I use this code, random search dot best estimator. It is saying me that C value is 2, random state is equal to 0, and solver is Saga. This Saga solver with a C value of 2 give me the best output for calculation. So what is the best score which it got is 99.6%. Now best parameters. So these are the best parameters: solver Saga, penalty L2, and C is to 2. So by using this one, I am generating a final model, LRF. I am using logistical regression with the parameters. After tuning, which I got it. I have used it. I am fitting this with XY train, and then YPRED. I have done it, and I have checked the scores. See. Logistic regression, F1 score. And this has not given me the best output yet. For getting the best output, we need to keep on tuning the parameters. Well, after certain tunings, we get a best output. Next, I'm going to check the accuracies of this one. So it is giving me 98%, which says that it has increased my accuracy by 1.5%. Before it was 97%, now it is 98.24% with 2.16 deviation. So I am going with this, but when you are doing this one in a production model, keep tuning it for multiple times so that your accuracy will be better. After this one, I am going to try this one on new data. This is the new data. It has to give me a result as malignant. I am just tuning. I am going to check this one on LRF, which is hyperparameter tuned. Now when I predict, it is saying that array, what is this one? So 1 means malignant, 0 means benign. So 1, it is saying that 1, then it is malignant. My projects has given me 98% accuracy. Thank you for watching. Subscribe, like and share.